The Fill tool can be found at the bottom of the Tools drop-down menu here. The Fill tool will create an internal fluid volume. It need not be specific to a fluid region, but it's essentially just extracting a new volume from the existing solid region. But the typical application would be to import a solid region and then extract the fluid region from that solid region, for example for an FSI fluid structure interaction case, or indeed just to do the analysis on the fluid region. And then the solid region in that instance would be suppressed so we can concentrate on the fluid. So we can see this example here of this solid section for this tank, and once we perform the fill operation, we extract the fluid region. That becomes a new solid zone, as it were, and then the original body for the solid region can be suppressed. Now, even though this is a fluid region that can be seen in the yellow here, that is identified as a solid body, but the solid body is just the naming convention given to the geometry type. It's not related to the physics to be applied to it. That will be set up when we move to the solver. And there are two methods of extracting the second solid body or fluid region in this case, and it can be done by a cavity approach, where we identify all of the surfaces inside, or in this case a wetted set of surfaces that make up all of the bounding surfaces for that new solid body. Or we can do it by caps, by identifying all of the faces on the boundary of the new fluid region, in which case Design Modeler can pass through the geometry and find all of the connected surfaces to build that new solid body or fluid region in this case. And here on the right hand side we can see the details views for those two cases, for bicavity and bicaps. And in the bicaps case we need to identify all of the bodies, all of the cap surface bodies that are going to be used in order to extract the new fluid region. Another option as far as creating an additional fluid region similar to the fill operation, but on the external, on the outside of the original solid body, is the enclosure tool, which is under Tools and Enclosure. And this will create an enclosure around the bodies, the existing bodies. So once we opt for enclosure, it will automatically find a bounding box for the existing bodies in the simulation, and it allows you to place a cushion around the outside of the existing bodies, and will automatically subtract the existing bodies as well. So essentially we're then left with the fluid region around the outside of the original body. So we select all the bodies to be involved in the subtraction. The shape of the enclosure, we have some control over the shape and also the extent as well, to control how long it should be. For example, if we're looking at flow over this aeroplane, we would want to ensure we have a large wake region to capture all of the vortices being shed from the back of the aircraft. And then the output would be a frozen body around the selected parts, based on the extents we specified in the inputs, and the internal flow would be the Boolean subtract result after the subtraction of the original body. But we can also support symmetry models if we need to slice it down the middle as well and only have half of the body, and we can have full or partial models to be included inside the enclosure as well. So here's an example of using the enclosure model. We start with this plain model example, which is a solid body, and then we go to the enclosure tool and we can choose the number of planes to be used, in this case for symmetry. So we choose the plane that will be used as the X, Y, green, red plane for symmetry, and it will also do the slice in that direction as well. And we can see here the cushions, the X, min X, max X, etc. for Y and Z in order to create the cushions. And this is the cushion beyond the distance beyond the bounding box of the zone up to the boundary of the new enclosure. So it places a cushion around it. It's quite useful to be able to create this, and then once it is created and subtracted, we can always go back into the command in the model tree and edit that command and change some of these values if we then decide we want to change a cushion in a particular direction. We can modify from there. So you can play around with it and make sure it's a reasonable size relative to the original body. We can also opt for our user-defined shape as well as a standard cuboidal shape. Here we can see this sort of torus shape that's been generated, and we can use that and identify that as a user-defined shape once that shape has been built for the subtraction. We can also use the symmetry tool, which essentially will slice down the middle of the body in order to create half the body. You must bear in mind that it's possible that even though the geometry is symmetric, that for a fluids calculation the fluid may not be symmetric. But in the cases where it's not unreasonable to assume a symmetry in the fluid and the geometry, we can slice the geometry into half. So here we have a tool which will do that operation. The inputs will be all of the selected bodies, which we can identify from the details view to be sliced. And we can also choose up to 3 symmetry planes as well if we have X, Y, Z as planes for symmetry for slicing. And the planes will then slice the model and we can remove the unnecessary parts. So here we can see the details view, the number of planes. In this case we've selected an XY plane and a ZX plane, and all bodies to be sliced. And here's an example of this model that's a single pipe that's then split into 4 separate pipes. At the top we have one plane for symmetry processing, and at the bottom we have the 2 planes for symmetry processing, and you can see the effect of specifying 1 or 2 planes for symmetry and what's left in terms of a 180 degree half model and a quarter 90 degree model.